Whatever the message we have, that is converted into packet, and that is done by the IP protocol or internet protocol. When the data moves from one layer to another layer, each layer is going to add unique address. When I consider datagram, each datagram must have the destination address. Hello to all, a warm welcome to my new session on the data link layer. I'm your Revati ma'am, faculty from the Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So dear student, in my last session, I started with elementary data link protocol. In that, we have discussed protocols for noisy channel as well as noiseless channel. Along with that, we have discussed sliding window. But in my today's session, I'm going to deal with some of the network layer design issue. Along with that, I'm going to deal with routing algorithm as well as flooding. So dear student, anyway, let's start my session with the concept that is network layer. So where we studied network layer in our OSI reference model, we have discussed network layer. Then what is the functionality of network layer? It is concerned with the delivery of data from source to destination. So it's mainly going to focus only the delivery of the data. And if I consider network layer, it's a third layer of OSI reference model. So it is majorly focused on getting packet. So it is responsible for transferring the data from source to destination via some routing, and it's also responsible for handling the error, and when error occur during the transmission of data, as well as it's also responsible for congestion control. So what is congestion? That's nothing but the network traffic. So these are the responsibilities of network layer. So dear student, I repeat, what is network layer? Where we can able to find the network layer in our OSI reference model. The third layer is network layer, and it is responsible for transferring the packet from source to destination. Along with that, it's also responsible for handling the errors as well as congestion control. Now, let us discuss the various functions of network layer. So, what is the first function of network layer? That is addressing. So, dear student, think that if I want to send any letter, then how I'm going to send? What are the thing I'm going to write? So dear student, in my address part, I'm going to write the complete detail about the sender. So if I consider network, here also, if I want to send the message, then I want to include the recipient address. And if I consider OSI reference model, and if I start from sender to receiver or receiver to sender, okay, from each layer is responsible for adding and removing the address. So dear student, in our network layer, when the network layer receives any message, okay, now the network layer is going to add the address. So here each layer is responsible for adding the address and removing the address based on sending or receiving. So dear student, if I'm going to send the message, then what I'm going to do? I'm going to add the address. So each layer is going to add the address. But think that I'm going to receive the message. When I receive from each layer, I'm going to remove the address. So here maintains the address at the frame header. So dear student, in my network layer, I'm going to consider message as my frame. Okay, now the job of the network layer is to add frame address of both source and destination. So at the source, I am going to add the frame address, and at the destination, I am going to remove the frame address, and performs addressing to detect various devices in the network. You may ask me that why I want to add frame address. So dear student, when I consider network segment, I'm going to have many devices. Now I want to identify each device uniquely. For that, I'm going to have the frame header. And another one is packetizing. So what is packetizing? See here, this is performed by internet protocol. So whatever the message we have, that is converted into packet, and that is done by the IP protocol or internet protocol. So the network layer converts the packet from its upper layer. So here network layer is responsible for converting the frames into packets for its upper layer. And routing. So what is routing? Routing is nothing but the best route used to transfer the data. Think that when I consider network, I have n devices. Okay, and to reach each device, I'm going to have n number of paths. In that, I want to select the best path or optimum path. So routing is the most important functionality. The network layer's first most functionality is routing. So what is routing? That's nothing but the choosing best route. Okay, choosing best route. So that is the main job of network layer. And the last functionality here is internetworking. It works to deliver a logical connection across multiple devices. So dear student, if I consider network, I'm going to have n number of devices, and I must have the internal connection between all these devices. For that, I must require internetworking. So these are the some of the functionalities of network layer. Okay, fine. Then what are the issues we are going to face while designing network layer? So the first one is store and forward packet switching. So what is my first design issue here? That is store and forward packet switching. And where we studied store and forward packet switching in our packet switching. So what is this stored and forward packet switching? So dear student, when source sends any data to the receiver, the intermediate nodes are responsible for receiving the message and store that message in their memory and forward that message to the next hop. So what is next hop here? That is nothing but the next intermediate node. So the host sends the packet to the nearest router. See here, think that I have 5 nodes and each node is connected each other. Okay, fine. This is my A and this is my B. Suppose A want to send any data to B, it's going to send the message to intermediate node, say Z. Now, the job of the Z router is to store the data in their memory and forward that to B. So, to establish or to design, store and forward packet switching is very difficult in our network layer, because if I'm going to have more than two router and each router is going to store the data and forwarding, so what's going to happen? That is delay in the message or delay in the packet delivery. So this packet is stored there until it has fully arrived. Okay, so whatever the data I'm going to send or whatever the packet I'm going to send, that must be stored in my intermediate router. So this is my first design issue under network layer. Now, service provided to transport layer. So dear student, if I consider TCP bar IP or OSI reference model, after transport layer, I'm going to have the network layer. Okay, now if I start from the receiver end, okay, think that I am the sender, okay, and I'm going to start from application layer. If I am the receiver and I'm going to start from the bottom, that is from the physical layer. See, network layer, whatever the service it's going to provide to the transport layer, it's going to face some problem. So through the network or transport layer interface, the network layer transfers its services to the upper layer. So this network layer is going to transfer all the services to the upper layer. So here, whatever the service it's going to transfer from network layer to transport layer, that is not depend on the routing technology or router technology. The transport layer needs to protect them from the number, type and topology of the available router, and network address for the transport layer should be uniform. So as we know that when the data moves from one layer to another layer, each layer is going to add unique address. Okay, so here the network address for each and every transport layer, it uses unique numbering pattern and it is called LAN and WAN connection. If I consider LAN and WAN, and if I'm going to have these systems in my LAN connection or WAN connection, each device must be uniquely identified by the address. So that is uniform numbering. And the another design issue here is implementation of connectionless service. So dear student, if I consider any network, I can have two kind of services. One is connection oriented and connectionless. If I consider connection oriented, then it is TCP. And what about connectionless? That is UDP. User datagram protocol. So here all the data are treated as datagrams. So packets are considered as datagrams. So packets are termed as datagrams. So here the message size that has to be transmitted. Think that if the message size is more than the datagram size, then what I want to do? I want to split that message into smaller datagrams and broadcast that datagrams. So in UDP, I'm going to broadcast the datagram. Each data packet has destination address and is routed independently irrespective of the packet. So when I consider datagram, each datagram must have the destination address. So this is also another design issue of network layer. Okay, fine. Then what is the another design issue we are going to have? That is connection oriented. So what is connection oriented? Before going to send any data from sender to receiver, there must be a physical connection between sender and receiver. In the sense what? There must be a connection. In the sense what? First, we have to establish a connection. Okay, then only we are going to send the data from source to destination. Use it and then release it. In connection-oriented service, the data packets are delivered to the receiver in the same order. So, in connection-oriented, how the sender is going to send the data? In the same order, receiver is going to receive the data. Okay, and it can be done in two ways. One is circuit switched connection and another one is virtual circuit switched connection. And if I consider connectionless, that is connectionless service, data are broadcast, so we don't have any proper ordering of received data. But if I consider connection oriented service, here we are going to follow the proper order of receiving data. In the sense what? If sender sends first packet, then receiver is going to receive first packet. Next time, if sender is going to send second packet, receiver is going to receive second packet. So the order of the packets are maintained here. And I'm going to have another very important topic, that is routing. Okay, fine. So what is routing? Think that I am in JAYALAKSHMIPURAM and I want to visit Gandhi Bazaar. I want to visit Gandhi Bazaar. And to reach Gandhi Bazaar, I'm going to have three routes from JAYALAKSHMIPURAM. Okay, fine. In that, what I'm going to do? I'm going to select only the shortest distance so that I can able to reach on time. Okay, so this is known as routing. In the sense what? Among all the possible routes, I want to select the best route. So here, if I consider computer network, I'm going to have the data. And to reach the destination, I'm going to have many path or many route. In that route, I want to select the best and optimum route, and that is known as routing. So, a routing is a algorithm, is a procedure that lay down the router or path to transfer data packet from source to destination. So routing is what? It's an algorithm or it is a procedure used to transfer the data from source to destination. But how I'm going to find the route? Here I want to consider or I want to focus only the best route. They help in directing internet traffic efficiently. After a data packet leaves its source, it can choose among the many different paths to reach its destination. Okay, fine. Think that I have A, B, C and D. Okay, now I want to send data packet from A to D. One possible route is direct connection and the another one is A to B and B to C. And the another possible route is A to C and C to D. See how many possible routes I have? 3 possible routes. In that, I want to select the minimum distance so that the data can be delivered on time. So, routing algorithm mathematically computes the best path. So, in routing algorithm, what I'm going to do? I'm going to construct the routing table. In that, I'm going to select only the best path. So, what is best path? That's the least path so that I can able to reach the destination. So, that is the least distance so that I can able to reach the destination. So, it is least cost path. From each path, I'm going to have the cost or weightage. In that, I want to select the least weightage. So, what is routing? It's an algorithm used to find the best route. So, dear student, if I consider routing algorithm, there are two types of routing algorithm. One is adaptive routing algorithm and another one is non-adaptive routing algorithm. And if I consider adaptive routing algorithm, further it is categorized into 3 types. One is centralized, isolated and distributed. And if I consider non-adaptive routing algorithm, then I'm going to have the flooding and random walk. Anyway, dear student, according to the syllabus, we have to study flooding. So, dear student, before that, let me to discuss what is adaptive routing algorithm. So, what is adaptive? Adaptive in the sense what? I want to adapt the feature. In the sense what? Dynamically, I want to change the route or dynamically, I want to choose the route. So here, adaptive routing algorithm is also known by the name dynamic routing algorithm. It makes the decision, it is responsible for making routing decision randomly or dynamically, depends on the network condition. Okay, fine. See here, I have A, B, C and D. One is A to D, another possibility A to B to D or A to C to D. Okay, and if I consider this diagram, this is the shortest path, but it is fully conjunction. Now, the job of the routing algorithm is to take the decision either route the packet that is from A to B to D or A to C to D. So, dynamically it's going to take the decision or randomly it's going to select the decision or select the path. They try to compute the optimized route. So, they are going to compute the best route depending on the hop count. So, what is hop? Next node or next device, transmit time and distance. So, what are the 3 popular adaptive routing algorithm? That is centralized, isolated as well as distributed algorithm. And if I consider non-adaptive routing algorithm, so it's a static. Okay, it is called static routing algorithm. So in my non-adaptive routing algorithm, at the beginning only I'm going to have the routing table. In that, I'm going to select the best route and I'm going to follow same route. So that is known as static or fixed route. So, non-adaptive routing algorithm is also called by the name static routing algorithm. It is used to construct static routing table. So, in my non-adaptive routing algorithm, I'm going to have the static routing table. Okay, so I'm going to construct the routing table and I'm going to follow only the fixed route each and every time. So the static routing table is constructed based upon the routing information and stored in the routers when the network is booted up. So dear student, in my static routing table, I'm going to store the routing information. Okay. So it is constructed based upon the routing information. Okay, which is stored in the router. So I'm going to construct the routing table, whatever the information which is present in the router. Okay, and when, that is when the network is booted up. And what are the two type of non-adaptive routing algorithm? That is flooding and random walks. But according to the syllabus, we are going to study flooding. So what is flooding? In flooding, when the data packet arrive at a router, okay, flood in the sense what? I'm going to send all the data packets together. Okay, fine. So flooding, when a data packet arrive at a router, it select all the outgoing links except the one it has arrived on. So it is going to collect all the packets. Okay, flooding in the sense what? The sender is going to send all the packets. So when a data packets arrives at a router, so sender is going to send all the data packets and the data packets are going to arrive at a router. It is sent to all the outgoing links and it is sent to all the outgoing links except the one it has arrived on. So it's going to send all the data packets to all the links except one it receives the data packet. So flooding may be controlled or uncontrolled or selective flood. So using flooding technique, an incoming packet will select. Okay, so here an incoming packet to A will be sent to B, C and D. So dear student, to illustrate flooding concept, let me to consider this example. Over, see, from A, okay, I can able to send packet to B, A to C and A to D. Okay, see, B will send the packet. So, first A is going to send the packet to B, C and D. Okay, now B is going to send the packet to E and D is going to send the packet to F and C is going to send the packet to F. Okay, fine. Now, this E is also responsible for sending the packet to F. So, dear students, see, B sends the packet to C and E. C is also send the packet to B, D and F. Okay. Then E will send the packet to, E is also responsible for sending the packet to F. Okay, now F can able to send the packet to C and D. Okay, in flooding, see here, we are not going to have any direction. See, if we are going to follow only one direction, it is fine. But Here we are going to use both the direction. Okay, data travels in both the direction. And if I consider the type of floodings are categorized into three types: uncontrolled, controlled, and selective flooding. So what is controlled? Before that, let me to explain uncontrolled flooding. That is unconditional transfer of packet. So each router is unconditionally transmit the incoming packet to its neighbors. Okay, in unconditional flooding, each router is responsible for transmitting the data packet to its neighbors unconditionally. So there is no condition. Simply they are going to forward the packet. Then what about controlled flooding? Controlled in the sense what? There is some condition. Okay. They uses some methods or some conditions to control the transmission of packet to the neighbor nodes, and the most commonly used controlled floodings algorithms are sequence number controlled flooding and reverse path forwarding. So these are the two algorithm comes under controlled flooding. Then what about selective flooding? As the name itself indicates that we are going to select the path. Okay, when the router receives the packet, the job of the router is to select the path among all the possible path. So it is best path or optimum path. The third type of flooding here is selective flooding. So as the name itself indicates that the router is responsible for selecting the best route. So here the routers do not transmit the incoming packets. So when the router receives any packet, okay, then router do not transmit the incoming packets only along those paths which are heading towards approximately in the right direction instead of every available path. Okay, when I consider computer network, that is when I consider the network, and if I have many routes to reach from source to destination, okay, and each router is responsible for transmitting the packet from source to destination based on the header. Okay, if I consider message, and each layer is going to add the address, and when router notice the address and which is the path to reach the destination. So here each message is going to have the headings or header value, okay, towards the approximately in the right direction. So each message is going to have the header information. Based on that, the router is going to transfer the packet from source to destination, and it is called selective flooding. Okay, instead of simply forwarding the packet, the job of the router is to identify the header address, then forward the packet to the corresponding intermediate node. So these are the three type of flooding. And dear student, in my next class, I am going to deal with distance vector routing, hierarchical routing, as well as link state routing. Anyway, dear student, let's meet in the next session with another important concept, that is routing algorithms. Until that, keep watching and keep learning. Thank you.